The City the Soul Abandoned, Mohenjo-Daro and the DNA Truth. Archaeologists found, when they began systematic excavation at a large mound of eroded brick in the Sindh province of what is now Pakistan in 1922, the remains of a city buried for approximately 4,000 years. A city that, at its peak around 2500 BCE, covered more than 250 hectares and housed an estimated 40,000 people, one of the largest urban centers in the ancient world, whose level of planning, sanitation infrastructure, and civic organization forced a complete revision of what scholars believed was possible in the Bronze Age. The site had been known to locals for generations. Bricks from its ruins had been used as railway ballast for the Lahore-Multan Railway in the 19th century, effectively mining an archaeological site of global importance, without anyone recognizing what they were dismantling. When the archaeologist R.D. Banerjee submitted a formal report to the Archaeological Survey of India in 1924, and when John Marshall published the first comprehensive account of the Indus Valley Civilization the following year in the Illustrated London News, the world learned that a Bronze Age civilization had flourished in South Asia at the same time as ancient Egypt and Mesopotamia, and had, in some respects, surpassed them both. The name Mohenjo-Daro is a Sindhi phrase meaning the mound of the dead. Whether this name reflects an ancient oral memory of the city's catastrophic end, or is simply a topographic description applied by people who found old bones in the soil, is not known. But the name proved apt. Beneath the mound were the remains of one of the largest cities in the ancient world, home at its peak to perhaps 40,000 people, organized with a geometric precision and a commitment to public infrastructure that had no parallel in the ancient Near East.
Physical evidence found in the uppermost archaeological layers of Mohenjo-Daro, the strata representing the final phase of the city's occupation, includes one of the most discussed sets of skeletal remains in South Asian archaeology. 44 individuals whose bodies were found not in formal graves, but lying in streets, on staircases, and in domestic spaces, in positions suggesting sudden death rather than burial. The skeletons were first described in detail by Ernest Mackay, who excavated Mohenjo-Daro in the late 1920s. Several of the individuals appeared to be grouped together, some holding or lying close to one another. The positions of the bodies, the absence of grave goods, and the lack of any burial preparation indicated that these individuals died and were never interred by surviving community members. Forensic analysis of the skeletal remains has been more informative about what did not happen than about what did. The bones show no systematic evidence of weapon injuries, no blade cuts, no embedded projectile points, no blunt trauma patterns consistent with organized violence. Whatever killed these people, it was not a conventional military assault. The two most credible explanations that the physical evidence supports are epidemic disease and flood. A rapid-onset epidemic could kill people faster than survivors could respond, leaving bodies unburied in public spaces. Sudden catastrophic flooding, documented at multiple periods in the Indus Valley, could have trapped and drowned people before they could flee. The skeletal evidence alone cannot distinguish between these possibilities, and it is possible that both, along with the broader climate deterioration discussed later, contributed to the city's end at different moments across its final decades. Genetic researchers found, when they extracted and analyzed ancient DNA from a female individual buried at Rakhigarhi, a Harappan site in the state of Haryana, India, representing one of the largest cities of the Indus Valley civilization, that the genetic profile of the Indus Valley people was distinct from any population that has been proposed as an external colonizing force, and that their closest modern genetic relatives are found among certain indigenous South Asian communities. The study, published in the journal Cell in 2019 by a team led by Vagish Narasimhan, David Reich, and their colleagues, analyzed ancient genomes from multiple Indus Valley period sites. The results showed that the Indus Valley people drew their ancestry primarily from a population the researchers designated the Indus Periphery group,
descendants of South Asian hunter-gatherers, with a smaller contribution from Iranian-related farming populations. Critically, the Indus Valley genomes showed no evidence of ancestry from the Eurasian steppe populations, the Yamnaya and related groups, whose expansion into South Asia is associated with the later introduction of Indo-European languages. This finding has direct implications for long-standing debates about South Asian prehistory. The Rakigahi DNA establishes that the people who built and inhabited Mohenjo-Daro, Harappa, and Rakigahi were indigenous to South Asia, not immigrant colonizers from the Middle East or Central Asia. The genetic continuity between Indus Valley people and certain present-day South Asian populations, particularly communities speaking Dravidian languages, suggests that significant biological continuity exists between the ancient civilization and modern India and Pakistan. Physical evidence found across the excavated portions of Mohenjo-Daro and other major Indus Valley sites documents a level of urban planning and engineering that, in specific technical domains, was not matched by any other Bronze Age civilization, and that remains impressive by modern standards. The sewage system is the most frequently cited example.
Every house in Mohenjo-Daro that has been excavated had access to a bathing area and a toilet, connected by brick-lined channels to a covered street drain that carried waste to larger collector drains outside the residential areas. The drains were fitted with inspection openings and appear to have been regularly cleaned. This is a municipal sanitation infrastructure that Rome would not equal for another 2,000 years, and that most cities in the world would not achieve until the 19th century. The standardization of materials across the entire Indus Valley civilization, which extended across an area larger than ancient Egypt and Mesopotamia combined, is equally remarkable. Bricks at every major Harappan site share an identical ratio of length to width to height, 4 to 2 to 1. Weights used for trade are consistent across sites hundreds of kilometers apart, following a binary and decimal system. This standardization implies either a strong central authority that enforced uniform standards across a vast geographic area, or a deeply embedded cultural consensus so durable that it persisted without coercion. And archaeologists have been debating which of these is more likely for a century without reaching agreement. The Indus script, appearing on thousands of small steatite seals, typically bearing animal images above short inscriptions, remains one of the few major ancient writing systems still unread. Bioarchaeological and chemical analysis found in the skeletal remains and material culture of Indus Valley sites has produced a picture of population health and diet that is, in several respects, remarkably sophisticated for a Bronze Age civilization, and that the Rakhigarhi ancient DNA study, supplemented with genetic data on disease susceptibility and population structure. Dental calculus analysis from Indus Valley skeletal remains has confirmed the use of turmeric and ginger in the diet as far back as 4,000 years ago, among the earliest direct chemical evidence for the use of these spices in human food. Residue analysis of pottery from Harappan sites has identified traces of animal fats, plant oils, and fermented beverages, documenting a diet that was more varied than the grain-dominated picture that early archaeological accounts suggested. The most surprising health-related finding from Indus Valley archaeology is the earliest evidence of dental drilling in human history, documented at the Neolithic site of Mehrgarh in Pakistan, a precursor community to the Harappan cities, dating to approximately 9,000 years ago. The drilled teeth show decay treatment using bow-driven flint drill heads in at least 11 individuals. The technique appears to have been borrowed from bead-making, which used similar drilling technology. The Rakigahi DNA analysis showed no evidence of the genetic variants associated with several epidemic diseases that would later devastate South Asian populations. a finding consistent with the possibility that the Indus Valley people had not yet encountered some of the pathogens that would emerge as domesticated animal herds and dense urban populations created new epidemiological conditions. Material culture found across Indus Valley sites documents a social world of considerable complexity, one in which craftsmanship, trade, play, and personal adornment were clearly valued, and in which the evidence for social hierarchy is more subtle and ambiguous than in contemporary civilizations like Egypt and Mesopotamia. The object known as the dancing girl is a bronze figurine approximately 10 centimeters tall, recovered from Mohenjo-Daro in 1926 and now held at the National Museum in New Delhi. It depicts a young woman standing with one hand on her hip and one arm covered in bangles, in a posture of confident stillness that the excavator John Marshall described as remarkable for its modernity. The figurine was cast using the lost wax technique, indicating a level of metallurgical sophistication consistent with the civilization's broader technical achievements. The seals for which Harappan civilization is perhaps most famous, small, flat, square objects carved from steatite, typically bearing an animal image above a short inscription in the undeciphered Indus script, number in the thousands from excavated sites. The most frequently depicted animal is a bull-like creature with a single horn that researchers call the unicorn seal, though whether the creature represents a mythological animal or a real animal depicted in profile is debated. The Pashupati seal, which shows a seated figure surrounded by animals, and has been interpreted by some as an early representation of the Hindu deity Shiva, is among the most discussed objects from the entire civilization. Dice recovered from Harappan sites are cubical, have dots arranged in the same opposition pattern as modern dice, and are among the earliest examples of this game technology found anywhere in the world. Paleoclimate data found in sediment cores, lakebed deposits, and pollen records from across the Indus Valley region documents the environmental deterioration that researchers now consider the primary driver of the Harappan civilization's decline, a multi-century weakening of the South Asian monsoon that reduced the agricultural reliability on which the cities depended. The research, synthesized across multiple studies published between 2012 and 2022, shows that the Indian summer monsoon weakened significantly between approximately 2200 and 1900 BCE, a period that correlates closely with the beginning of urban decline in the Indus Valley civilization. The weakening was not a sudden collapse, but a gradual reduction in reliable rainfall that made the large-scale grain agriculture underpinning the cities increasingly difficult to sustain. The Saraswati River, identified with the mythological river of the same name in ancient Indian texts and corresponding to the now dry Ghaggar-Hakra river system in northwestern India and Pakistan, was a major axis of Harappan settlement. Geological and remote sensing evidence indicates that this river system dried up significantly during the period of urban decline, as its source glaciers shrank and its tributaries were captured by other drainage systems. The loss of a major river would have been catastrophic for the agricultural communities that depended on it. The Harappan response to this environmental stress appears to have been gradual dispersal rather than sudden collapse, populations moving east and south toward the Ganges Plain and the Deccan, where monsoon reliability was better. The cities did not collapse suddenly. They were slowly abandoned as the conditions that had made them viable eroded over generations. Physical evidence found in the archaeological stratigraphy of Mohenjo-Daro includes layers of burned material and ash at various levels throughout the site, evidence of fires whose cause and significance have been interpreted in ways that range from straightforward archaeological explanation to the most extravagant speculation in the popular literature on ancient civilizations. The confirmed facts are these. Fires occurred at Mohenjo-Daro at multiple points in its occupation history. Several areas of the site show evidence of burning consistent with domestic or industrial fires that spread. The skeletons found in the uppermost layers show no systematic evidence of burning. The city was built primarily of fired brick, which does not burn, and its construction in this material was deliberate and consistent. The fringe theory that has circulated since the 1970s holds that the burned layers represent vitrification, soil transformed into glass caused by an ancient nuclear explosion, corroborated by elevated radiation levels in skeletal remains and referenced in the Mahabharata's descriptions of a mass destruction weapon. Every specific claim has been examined and found either fabricated or misrepresented. No vitrified soil has been confirmed at Mohenjo-Daro by any peer-reviewed geological analysis. Radiation measurements show no anomalous levels. The Mahabharata passages were composed centuries after the city's abandonment. The real mystery of Mohenjo-Daro's end does not require invented physics to be genuinely puzzling. A civilization of extraordinary sophistication dissolved over centuries, and the full story of why is still being worked out. Population genetic research published since the Rakhigarhi study has extended the analysis of Indus Valley genetic ancestry into the present, tracing the biological continuity between the people who built Mohenjo-Daro and the populations of contemporary South Asia, and identifying specific genetic variants that may reflect adaptations developed during the Harappan period. The ancient DNA from Rakhigarhi and related sites clusters most closely with the Irula people, a tribal community from Tamil Nadu in southern India who speak a Dravidian language and who represent one of the populations with the deepest roots in South Asian genetic history. This connection is significant because it suggests that the Indus Valley people were ancestral to at least part of the Dravidian-speaking population of the Indian subcontinent, a finding that lends genetic support to the linguistic hypothesis that Dravidian languages preserve the cultural continuity of the pre-Indo-European South Asian civilization. The genetic variants associated with the Indus periphery ancestry that characterize the Harappan people include adaptations to South Asian dietary staples and to the climate conditions of the region. The ability to efficiently metabolize the grain-heavy diet that Harappan agriculture produced is reflected in variants of amylase genes, enzymes that digest starch, that are present at elevated frequency in South Asian populations compared to populations with shorter agricultural histories. The political sensitivity of these findings in South Asian nationalism has been significant. The Rakhigarhi results directly challenge the narrative associating South Asian civilization with Aryan migration from Central Asia, and their reception illustrated how deeply questions of genetic ancestry can intersect with contemporary identity politics. Scientific synthesis found across the archaeological, genetic, and paleoclimate literature on the Indus Valley civilization presents a picture that is more nuanced than either the dramatic collapse narratives or the romanticized continuity stories that have characterized popular accounts. A picture of a civilization that adapted, dispersed, and ultimately dissolved into the populations of a subcontinent it had already shaped in ways that persisted long after its cities were silent. The undeciphered Indus script remains the civilization's most tantalizing legacy. Thousands of inscriptions survive on seals, pottery, and copper tablets, a writing system used across nearly 1 million square kilometers for approximately 700 years. Every decipherment attempt has failed to produce consensus. Without the ability to read the texts, the internal organization of Harappan society remains effectively invisible. What the DNA evidence has clarified is continuity. The Indus Valley people did not disappear. Their genetic ancestry flows through South Asian populations today, detectably present after millennia of admixture. The Irula connection the Dravidian language link, the agricultural genetic adaptations. These are biological traces of a civilization that built the world's first urban sanitation system and left no readable words to explain itself. The civilization that called itself, in whatever language its script encodes, by a name we cannot yet read, built cities that lasted longer than Rome, traded with Mesopotamia, and declined not because of military defeat, but because the rivers changed and the rains failed. Its people walked east and south, carrying their genes and perhaps their memories, and became the ancestors of hundreds of millions of people who do not know their names.